So I'm Jason Chan. I'm a director of engineering at Netflix, and I'm responsible for security. And what I want to talk about today is, how do we get all of our, we have a bunch of apps that are in systems and data that have some kind of compliance sensitive, obligation, right? So how do we get those to the model of development where we can use things like microservices and NoSQL and cloud and agile DevOps, all that kind of fun stuff, and without having developers and auditors kind of ripping each other's hair out. So that's what we want to talk about. Just clicking again. Oh, there we go. Sorry, behind one. So when I think of 2015 for developers, it's kind of like a kid in a candy store, right? Where you have all these new languages, all these new frameworks, really optimized for getting ideas out of your brain and into production as soon as possible, as really as quickly as possible. And the same year, but for a different audience, right? Auditors and security teams, it's kind of like walking into a room with a bunch of mouse traps all over. Like every step is kind of fraught with peril. There's something going to go wrong. The pessimists in the room will probably say that's kind of every year for security people. That's how we always think. But really now with all this new change, it's an interesting time. And to me, kind of digging into the problem a little bit more, it's about the incentives and perspectives for each of those groups. Because as developers, which I know most of you are, you think about what you're asked to do. You're asked by product managers and by the company to create awesome products and great new features as quickly as possible, because that's kind of how competition works, right? You need to move fast. And if you're asked to do that, the reasonable sort of response is, well, you want to have freedom to innovate. You want to use the technology that makes the most sense. And auditors, it's not that they're anti-business. I mean, they want the company to be successful. We understand you need to move fast, but there are systems that you do have regulatory obligations that need to be met. And when we map that to technology, how we typically think is we want to have well-known technology. We want it to have gone through audits before. We want predictability, we want stability, all that kind of things. And that's what sort of drives this tension, right? And to me, what resolves that tension, it's more of an operational change that's really embodied in this quote, which you've probably seen before from Werner Vogels, who's of course Amazon's CTO. It was actually almost 10 years ago. It's you build it, you run it. So if you're building production software, you're going to be responsible for running it. So that's kind of the core of DevOps, right? So there's no more throwing stuff over the wall and letting somebody else handle it. And when you're a developer and you have to operate your system as well, it really drives vastly different behaviors in the design, what kind of monitoring you have, what kind of tooling, how you interface with that system. And the interesting thing that has been kind of an interesting discovery for me is that the change in that mindset for developers is exactly what auditors want. It's how auditors think. And to maybe make a little more sense out of that, take a look at these questions and sort of think, who's asking those? So if you get the proverbial call at 2 a.m. and something's broken on Netflix, right? And you're on call, you want to know the answers to these things because it really speaks directly to your ability to be able to support the system. And auditors, they're not supporting the system, but they need to verify the system. So not to completely oversimplify an entire industry, but technology auditors are really, it's about verification. So does this system produce accurate financial reports? Does it protect credit cards? Those are the kind of things that an auditor needs to verify. Same questions. So now where we want to get leverage from is you have two different audiences that are asking the same questions. So that's kind of how we want to operate. And we want to go kind of from this model where we might have thought kind of tug of war to more of like the sort of best friends approach, right? This is the goal. We want developers and auditors to be happy, to be hugging and kind of frolicking together. But obviously you don't wave a wand. There's some work to make that happen. And in terms of how we get there, I've worked in security pretty much my whole career, and most of that career is also somewhat involved in compliance here or there. And there's kind of two approaches to compliance. And one of them is what I call a checklist approach, where you basically say, well, what am I responsible for? And then let me just one line item for each thing. The problem is, well, there's a few problems. If you're any kind of complexity, you probably have multiple regulations to adhere to. So then you just expand it. You have duplication of effort. Sometimes things change. And there's also, to me, which is important in terms of somebody who kind of runs a team, is that there's a human element there, where people don't get really jazzed up about going to work saying, hey, I'm going to check some compliance boxes today. That doesn't get people excited. And then the other approach to that, what I'll call like a pillar-based approach, is where you're saying, hey, look, regardless of any particular regulatory requirement, I'm just going to design things around these sort of core operational principles, these core design principles. And then that's how I'm going to build my system. That's how I'm going to build tools and interfaces. And as a result of that, I'm going to be able to meet compliance requirements. And we'll look at some examples of that. So the way I call it, and this looks like a little bit of a kind of a marketing phrase, but the adjectives I think are accurate because it's effective in that it will allow you to meet requirements. It's efficient in that it's going to save you money and save you resources. And it's flexible in that it allows you to meet multiple requirements. So it's not just one thing. And so the pillars that we'll talk about today, 3 of them. One is traceability and development. The second one is continuous security visibility. And then the third is compartmentalization. So we'll do a little bit of a deep dive in each one of these things and see some examples. And then the general format, what we'll do is sort of explain what I mean by each pillar. I want to take a look at some examples of stuff that we've done at Netflix to kind of embody that pillar in our operations and tools, and then show how that maps to regulatory compliance. So you don't need to know anything about regulatory compliance, but we'll sort of close that loop just to show how it all works. So diving into the first one, which I'll call traceability and development, you know, if you're on a big team or you have a lot of developers, you have a big system, distributed system like Netflix, these kinds of questions are really important to be able to, or these kinds of items are really important to be able to do. And the same thing that auditors want. Like auditors want you to test your changes. They want you to review your changes. But really developers, I mean, generally if you're responsible for your system, you're going to want to do these things anyways, right? So the way that we kind of make this pillar come to life is a system that we built called Spinnaker. And Spinnaker is a system we're actually, kind of good timing, we're actually going to open source it next week. So keep an eye on our tech blog for that. And basically what Spinnaker is, it's a system for continuous deployment. And what it allows you to do is it has this concept of pipelines or workflows. And you as a developer or a development team, you compose your workflow however you want, based on whatever your requirements are. You want to insert tests here. You want to insert restrictions here in terms of what region you might deploy to. Oops, went backwards there. Gives you a single interface to your entire deployment process. And then it answers all those questions, the who, what, when, why, for developers and auditors. Just one place to go to serve multiple audiences. That's really what we want to do in terms of leverage. So this is just a little bit of an overview of some of the stuff that we'll look at. We'll talk about integration to development. We'll talk about push authorization, restrictions around deployments, and then deployment notifications. So this is a view of Spinnaker. And so we run in AWS, Amazon Web Services. If you're familiar with AWS, it doesn't really have the idea of an application. It's kind of, an application in AWS is kind of an aggregation of a bunch of like cloud primitives, things like load balancers and security groups and IAM users and a bunch of other stuff that you need to kind of cobble together to run your app. So what Spinnaker does is it takes an app-centric view and it gives you a view of all that. So this app here is called Play Ready and it has all your interface to all your bits there. And then each one of those horizontals is what we call a pipeline. And what Spinnaker also does is allows you to link right into your build system. So we happen to use Jenkins, get to all your build artifacts, all your build results. We use Stash, or I think it's called Bitbucket now for source code management. Get a link into all the code that changed, that triggered this build, all the pull requests, all that stuff available in one place. And then the core of Spinnaker, as I mentioned, is this idea of a pipeline. And that's what these horizontal lines are. Each one of those blocks is a step in the pipeline. And you as a developer create pipeline with 1 step, with 15 steps. It doesn't matter. It's meant to be tailored to your requirements. You see we have multiple deployment stages. Some of them are automated, and then some of them are manual. And you've probably never seen Spinnaker before, but you can probably associate the green and the red. Green, good, red, bad. So red, this particular one means that a test failed. So we had some kind of test in our pipeline. It failed, so don't proceed. So let's dive into that test. And that test, what happened to fail was what we call automated Canary analysis. And you may be familiar with Canary testing, kind of like A/B testing for your code, where you'll take the new version, send it into production alongside the old version, take some traffic, run some tests, run some metrics, and then decide if you want to promote it. And with automated Canary analysis, that's totally hands-off. So if it passes your if it passes your test, go ahead and promote to production. There's no reason to have somebody involved. So this is the exposure in Spinnaker to that entire interface. You'll see here the Canary test score. So we actually did a Canary test in 3 regions, in Europe and West Coast and East Coast. 1 of them it passed, 2 of them it failed. It gives you links right to your test results. So you don't need to go digging to see what went wrong. And then it just gives you the results there. So you have this integrated testing. We saw earlier how we had integration to our CI system. Next is the idea of a manual approval. So even if you went through the automated Canary analysis and everything passed, it looks great, it scored 100, sometimes you just need to have somebody give a thumbs up. And a lot of times with regulatory workflows, you need that. Somebody needs to say yes. So if I were the one to say, yes, let's push this, it would capture that information. Then that becomes an artifact so that people who are supporting the system understand that. They know they can blame me, and then auditors also know that, okay, well, Jason's the one who did this change. We also have the idea of a restricted deployment window, because over time, what we found is that it's not a great idea to deploy code right during the peak of your production time. So that's a good idea, it's a good practice, but why not just go ahead and make that part of your workflow? So that's what Spinnaker lets you do. And right here, basically what we're saying is only execute this pipeline between 4 p.m. and 10 p.m. So any other time, it's not allowed. You can also restrict by regions. So we've also found it's generally not good to deploy globally. So we'll deploy maybe to Europe first, and then East Coast, then West Coast, kind of a phased deployment. You can do it all automated. You can insert manual as needed. And then lastly, we'll see this idea of a deployment notification, so that every step of your pipeline, you can be notified by email or SMS. You can do like a chat ops integration, anything like that, just so you have full visibility. And then kind of, if you think generally about deploying code with Spinnaker versus manual deployments, what Spinnaker lets you do is deploy completely independent of languages. So you don't need to know, well, how do I get this jar file or war file or anything? It doesn't matter. Python, Linux, Windows, all gets deployed the exact same way. And you have you have multiple stages of automated testing that you have access to. So integration, security, Canary testing. And then it's a fully traceable pipeline, right? So you can go from what's running in production and you see, well, who did that push? Who authorized that? You go back another step, you look at the build artifacts. You go back another step, you see the code that changed. You see the JIRAs that were filed to make those code changes. So it's all right there. It's a very nice tool for developers to be able to support and auditors to be able to verify. And then sort of mapping that to control. So this is kind of the auditor part of it. When PCI is around credit card security, SOX is around financial reporting. They both tell you that you need to test code before you deploy. And then PCI also requires you to do code reviews, and we saw how that's integrated there. So sort of how that works is you think of this principle, which is traceability and development. You think, hey, that's a good idea, we want that. So then you build tools around that, and then the outcome is that you're able to meet regulatory requirements. That's kind of the cycle that we follow. The next one, it's kind of related. It's the idea of continuous security visibility. And as a security team, especially in a large environment, things change all the time. And I need to know, do those changes have some kind of impact on the security posture? So what we do, if you think about it from an application portfolio perspective, you have a bunch of apps, and you need to decide which one of those are most critical and where should you be spending your time. The problem with how we do that now is we usually do spreadsheets and we ask people to fill them out, and then we make some decision about the criticality. The problem there is that humans lie, kind of intentionally, unintentionally, they answer ambiguously. It supposes that you're actually going to capture everything, and you're going to be able to get a spreadsheet in front of somebody. And that's it's sort of anti-innovation, because if somebody has an idea, their first thing, about a new app or a new feature, their first thought isn't, hey, let me go check with Jason to see how risky this might be. It's, let's test something out. And then it tends to be one time. So maybe you do it once, but as code changes over time, it gets out of date. So you ultimately have this system that's it's full of errors, it's non-comprehensive, and it's out of date. But that's really the best we have in terms of resource allocation. So we think we can do better than that. And kind of the nice thing about moving to this new model of development is that it makes it much easier. So I saw this tweet a few months back, and it really captures the kind of idea of microservices where, the microservices, the idea is to simplify, but once you get a big distributed system, you can't really keep it in your head. but that's what computers are for, right? So you use computers to automate your awareness and your analysis. So that's what we did when we built a system that we call Penguin Shortbread. And kind of for lack of a better catchphrase, it's automated risk analysis for microservices architectures. And basically what it does, it doesn't involve humans. What it does is it looks to see how microservices actually talk to each other, and it observes different characteristics about the application. And then based on those observations, it sort of reasons over that data to get some kind of decision about how risky is this app. And then that's how we make decisions. So the core to Penguin Shortbread is an application risk metric. This particular one we call the dependent applications risk metric. And the idea is that if a bunch of systems depend on my system, then my system is sensitive. It's not a perfect metric, but it's kind of a proxy. And the idea is that if you make lots of these metrics, and maybe each one of them is imperfect, but more observations give you a better view of it. So that's what we try to do. And this metric's pretty simple. You see the algorithm there, it's just a little bit of Ruby code there to sort of calculate how many dependencies are calling this one. And then what we do scoring-wise, basically, hey, if between 50 and 100 systems depend on this server, I'm going to call it high, I'm going to have a high risk in terms of dependency. And then what you do is you make as many observations as you can that you think will give you some kind of insight into the risk or the security posture of it. And then you calculate that. So this is an app called Cryptex. These are all the metrics that we would run. And these are the scores across regions and across tests and across production. And the idea is that as a security team, you would say, well, let me look at my riskiest apps, and that's where I want to focus my attention. So it gives you some kind of knowledge, and you're not relying on human input, and it's always up to date and comprehensive. Then mapping that to things like PCI and SOX, PCI tells us restrict traffic, and that's what Penguin Shortbread helps us do because it knows exactly what needs to communicate. And both PCI and SOX actually tell you that you have to have basically a risk assessment process. And that's what Penguin Shortbread helps us do as well in an automated way. And the last sort of principle or pillar I want to talk about is compartmentalization. And this is very key when you think about distributed systems in really two dimensions. The first one is resilience. So a lot of times you'll hear the phrase limiting blast radius, and you'll hear about like bulkheads where you're trying to these kind of inner walls in a boat that prevent the boat from sinking. It prevents too much water from getting in. You're limiting how bad something can get. And then there's also the dimension, which is more security-centric, around confidentiality, right? So if I have a secret and I want to keep it secret, don't tell people, right? It's about need to know. If people don't need to know something, then don't tell them. And then we want to use this to our advantage, and it'll help developers and auditors. And the example I want to use is kind of integrates you'll hear about the monolith to microservices migration. You'll hear about kind of data center to cloud. And so I want to talk about how we moved our payment systems, basically credit card processing, to the cloud. So we used to have, the data center, pretty typical. You have a payments application. You have people signing up through a website, right? Giving you your credit card. From there, what we would do is we would call an HSM or a hardware security module to encrypt that data. And then you store that in the credit card database. And then you have some kind of, obviously this is simplified, but you have a record like that, right? John Doe and then their encrypted credit card. And then the payments app, it calls out real-time and batch processing, and it talks to a bunch of systems like tax systems and fraud systems and analytics. And the problem with, well, I wouldn't say a problem, but the argument against a monolith from the developer's perspective is that it's a lot of functionality tied together, and it's hard to kind of iterate and sort of innovate without knowing you're going to break something. Everybody has to kind of be aligned, and it's difficult to kind of move at different speeds. The problem with monoliths from a security perspective is that every piece of functionality is something that could go wrong. It's something that can fail and have a security problem. And when I look at this kind of architecture, you have very sensitive systems that have a lot of inputs and outputs. And we call that, in security, we call that attack surface. So things with a lot of attack surface, it's not that they can't be secured, it's more difficult to do it. And it's more difficult to verify that things are actually working as you want them to do. So let's take a look at this model, and then as we transitioned it to the cloud and kind of went more microservices, sort of exploded this model. So you still, at the core of it is your payments application. You still have people signing up, hopefully, and through a web server giving you a credit card. And this is kind of where things change, because this is where you implement what's known in the industry as a token vault. And a token service does what's called tokenization, which is really, I mean, it's simply just taking a non-sensitive value and substituting that for something sensitive. So if you have something like a social security number or a credit card number, don't pass that around to everything, right? Keep it in one place, then have a label, a token that maps to that, and then pass that around. That's the safe way to do it. And then you store that sensitive data in your token vault. So now what we do is we call the token vault. The token service calls a bunch of crypto infrastructure and basically then stores within the token vault a mapping that looks more like this, which is a token to an encrypted card. So now you don't have that personal information there. You don't have John Doe's name there, so you've decoupled that. And then the payment app kind of does its thing, and in the payments database, you store the mapping of the user to the token. So what you do here is you reduce the attack surface and you make it much more traceable in terms of what's going on. And then you're basically, it's not that you don't have sensitive information here, you still do, but the idea of segmentation allows you to implement much finer grained access control, because here the token service, the only thing that's allowed to talk to the token service is the payment app. The only thing that's allowed to talk to the crypto proxy is the token service. So it's very easy to tell what's going on versus that monolith where everything is kind of scrambled together. And then mapping that to the controls, it's kind of funny because PCI, people complain about it all the time. It's the regulation around credit card processing. PCI has had this requirement for a long time of only one function per server. So I kind of say PCI has been recommending microservices for a long time because it simplifies things and it makes it easier to secure. And then both SOX and PCI require you to basically manage security, and that's what segmentation and compartmentalization helps you do. So just kind of wrapping up in terms of takeaways or recommendations, I really tried to get folks to limit investments that really just solve a very narrowed regulatory need. So anytime you think you're investing because, hey, we need to meet this particular requirement, that's kind of like an anti-pattern or a bad discussion to be having. You want to be thinking about how can you get more to the idea of designing around core principles. And then, because I think when you do that, you can then focus on tools and these techniques and processes that really benefit everybody. It's not just, hey, we do this just for auditors or we do this just for security. You're just doing the right thing and then everybody benefits. And then hopefully that's kind of the key to actually getting there. I think we have maybe a couple minutes for questions, but thank you for coming in.